Hey everyone, my name is Sebastian and I'm one of the co-founders of DC Spark. And today I'm going to talk about a new project that's got a few people excited called utxorpc. So it fits in nicely to the existing tapestry of indexer solutions in the Cardano space because there's a lot of different existing projects. I want to talk about utxorpc and what it does, but also how it compares against other solutions that already exist out there. So you have an idea of when this is useful, how it's useful, and what other solutions exist. So maybe to take a high level approach first, imagine you want to write a dApp that leverages Cardano. What steps do you actually need in the pipeline to actually build an application? Well, first of all, of course, you need a node to actually be able to synchronize the blockchain. Now, once you have a node running, you need to be able to get data out of the node. So, for example, you might be interested in some transactions, some blocks to power your dApp. Now, usually the node in Cardano, because it's very small on purpose to give it a small memory, small CPU requirements, small storage requirements, the data you can get out of it is not usually in a way that's easy to use with dApps. You usually need to transform it. So, for example, you get a bunch of blocks, and you want to extract information from those blocks. For example, you want to know information about maybe some UTXOs for your dApp, or maybe some list of users that have interacted with your dApp. So you want to extract information from it and then store it somewhere in a more optimized format for your specific application. So usually you'll have some kind of storage system that stores the data in a way that's optimized for your application. And then lastly, once you have some data that's optimized for your application, you want some way to fetch that data, for example, to show it inside your UI to power your actual dApp itself. So you have 4 steps. You have the node running, you get data from the node, you transform the node into a format that's good for your dApp, and then you fetch that data. So given that there's 4 steps to this pipeline, let's go over the kind of key projects in every step. And keep in mind that some of these steps have specifications. So for example, Cardano has a Cardano specification that handles the actual node. So if you look up Cardano specification online, you can find actual specifications for exactly how the node is going to work. Now, there's multiple projects that implement that specification. The main one, of course, being Cardano Node, which is the Haskell implementation of Cardano. Now, Cardano Node, as I mentioned, obviously gives you a node functionality, but does not really give you much of a way to get data out of it. It's purposely kept slim on purpose to lower the requirements to run a node. Because of that, it also does not really give you any kind of storage system or any kind of way to fetch data optimized for your application. So it really focuses on just being node and just handling that part and just implementing specification to kind of give you the minimal set of what you need. Now, there's another project that's similar to this that's written in Rust instead of Haskell called Amaru, and that's by the Pragma coalition. So similarly, that tries to be a node, but not as focused on the other parts. Now, there's another project called Dolos, which is by a company called TXPipe, that is kind of a node, but it does not implement the full node functionality. It only implements part of it. And the goal of Dolos is to be kind of a more data-oriented node for Cardano. So it gives you some of the node functionality, but also gives you some way to get data out of that node. And also it comes with like some amount of storage system. And also some ability to fetch data out of it. So it tries to cover some parts of the full intent to try and make it easier to use this as a base to power your application compared to Cardano node, which has much lower requirements, but it's much more limited in its feature set. Now we talked about getting data, but actually there's a specification for getting data out of a node as well called mini protocols. So you ever heard of mini protocols in Cardano? This is the specification for how to get data outside of the node. So there's another node being written in Rust by Blink Labs in Go, but we're going to skip that for now and now talk about the projects that are trying to get data. So one you might have heard of is Aura, which is written in Rust and is mostly focused on streaming events. So it's built in Rust and has this functionality. But but does not really implement anything else. So obviously, it's not a node, and everything else we're going to talk about in this video is not going to be a node. So we can just block out this entire section. But Aura does not come with any kind of storage system. It's just purely getting events out of the data or out of the node, and because of that, it also does not really give you any way to fetch events. Now, there's some other projects that are kind of similar in that idea. So, for example, you might have heard of Ogmios, which is by Katos, which is one of the Cardano very well-known developers, and that one is in Haskell instead of Rust. You might have heard of another one called Adder, and that one is in Go, if I remember correctly. You might have heard of another one called Yassi Store. And Yassi Store is in Java. And then you might have also heard of DBSync, but we're going to answer that one in a bit. So notably, the important thing is the projects I just mentioned, they typically are focused just on getting data out of the node. So you connect it to a Cardano node, you say I want to get data out of the Cardano node, and it uses the media protocol to get data out of it. And it's not really focused on a storage system, except for Yassi Store, which does have some storage support through Postgres. Now, there's some projects that kind of span over multiple of these rows, and one of them is called Cardano DBSync, which is written in Haskell, and it can get some data out of the node, but more importantly, it stores a large Postgres database, a very large Postgres database that stores basically everything you could possibly want out of the Cardano node inside Postgres. So it takes in basically almost the entire blockchain state and re-represents it as a Postgres database for people who want to be able to easily query on top of that data, but does not give you any way to easily fetch that data. Rather, it's just a storage solution. And that's written in Haskell and managed by IOG. Now, because Cardano DBSync is a very large system where it stores the entire Postgres database of the entire blockchain state, it takes a lot of memory storage and all those things. So there's a lot of solutions to try and limit the amount of data you might need. So for example, you might have heard of Carp, which is by us at DC Spark. And Carp is also Postgres based, but it's limited. So it does not fetch everything. Rather, it just only gets tables you need for your application. And it provides some small REST endpoint on top of it, but that's not really the core focus. And it needs to pair with another tool. For example, you pair Carp with Aura. So for example, you see Aura's over here handling the get data. So you would basically run a Cardano node to have the initial data, have Aura to fetch data from the node, and have Carp to store that data from the node. So you can see how these different tools kind of chain together to get you different parts of the stack. So another one is called Scroll, and that's by TX Pipe. And Scroll is mostly focused on, instead of storing to Postgres, it's more focused on in-memory solutions like Redis. Let me take green for that. So the advantage of Redis is much faster to query. The disadvantage is it takes a lot more memory, and by this one's written in Rust as well. But again, this one provides no kind of fetching layer beyond what Redis itself gives you. So another solution out there is called Kupo. And that's again by Katos, that also wrote Ogmios. And Kupo also is not focused on getting data, but it's also focused on storing data through Postgres, notably through pattern matching. So it's less optimized than a solution like Carp for fast data retrieval, but it's more focused on being able to handle arbitrary patterns, which is less engineering work for the dApp, but comes with some potential performance trade-offs. And Kupo does have some ways to fetch data out of it, but it's not as much of a priority, and we'll see why in a second. Now, once we have these storage solutions out there, the question is, well, how do we fetch data out of it? And similarly, again, there's different projects out there trying to handle this fetching story. So one of them, sorry, give me a second. One of them is Blockfrost. So Blockfrost is an API that primarily works on top of Cardano DB Sync that we saw up here. And it gives you a REST API to get data out of it, but does not give you any other part of the stack. It is mostly just focused on serving data primarily from DB Sync and some other services. So that's Blockfrost. Next, we have Koyos, which is focused on Postgres, which is a tool to generate REST endpoints from Postgres database, and this is also based on DB Sync. Let me extend my table. So again, no storage. This is just mostly focusing on serving through a REST endpoint the Postgres data. There's another one called Cardano GraphQL, which is again built on top of Cardano DB Sync, and this one just provides you a GraphQL interface. I think this one word, GraphQL, but does not handle anything else. And finally, we get to the last part, which is utxorpc, which is the latest tool coming into this ecosystem. And this one is focused on gRPC. And notably, it has a spec as well. So it's not just fetching data, but it's also a specification for how to create a utxorpc compliant way to fetch the data. And again, it doesn't solve any of the other boxes. So the idea of utxorpc is right now, historically, we've had kind of two ways to get data, which is the REST endpoints to fetch data for your dApp, as well as the GraphQL. Now, the problem with the REST stuff is that it's often a bit harder to get the flexibility that you might want for an efficient application. So imagine you have some endpoint that returns a lot of data, but you actually only need a subset of that data. In REST, it's a bit hard to say like, oh, I just want this specific information for this specific data. So it's a bit less flexible, but very easy to use. So it's very beginner friendly. GraphQL tries to solve this by being a lot more complicated. So GraphQL allows you to say, okay, I want this exact data for this specific thing, and give me the query that gives you exactly that. So it allows you to fetch a lot less data that you don't actually need and pinpoint a lot more precisely exactly what data you want. But the downside is it comes with some performance problems. And so this GraphQL stuff will be a lot slower from a performance perspective than the REST endpoint, but it saves you a lot on amount of storage, or sorry, amount of data that has to go over the network. And gRPC ends up being kind of an in-between. So it allows you to get more fine-grained information outside of the endpoints you query, but do so in a way that's a lot more performant than the GraphQL implementation that exists. And it does this through using a tool called Protobuf, which is by Google, to encode information in binary format that is a bit harder to work with, but ends up being a lot more efficient and easier to specify exactly what kind of data you want to get out of it. And one of the key things about this utxorpc project is that it does not just come with this, kind of this gRPC implementation that you can use to actually get data for your dApp. It is also a specification saying exactly what endpoints you need to expose and how to do it to be able to conform to the utxorpc specification. And so the benefit of this is that other tools out there that already exist, so for example, Kupo, which, as you might remember, I mentioned earlier, has some kind of pattern matching system for their fetch data. They could change their pattern matching system to be supporting the utxorpc specification, so that you could use Kupo to power this kind of utxorpc compatible application. Similarly, other nodes, like for example, Dolos, which I mentioned up here, is a node that tries to provide some amount of ways to fetch data. And so one of the ways that they hope to be able to expose data from the node is through this utxorpc. So by running a Dolos node for Cardano, you would automatically get a utxorpc compatible specification that allows you to power dApps when that's all the information you need for your dApp. So as you can see, utxorpc provides a different data format for getting data out of the node, and also importantly, it tries to help not just be a implementation, but rather a specification that other tools in this column can target, or other tools in the node column can target, to try and make it easier to have a uniform way of querying data in certain situations to improve composability inside the Cardano ecosystem. So I know this was kind of a lot of projects to go over, but hopefully it gave you a better idea of the different indexer solutions in the Cardano ecosystem, what utxorpc is doing, and how it's complementary and additive to what the ecosystem already has. Thank you very much.